Recording in progress.
All right. Now welcome to this video lecture on linear functions. Linear functions. So this is just a review to what you've learned in your previous math class on linear functions. So in this section, we are going to learn how to represent linear functions, how to determine whether a linear function is increasing or decreasing, or constant. We're going to learn how to calculate the intercept, calculate and interpret slope. We'll write point slope form of a linear equation and also interpret a linear function. So let us start. What is a linear function? A linear function is a function whose graph is a line. Done. The graph is a line. Say we have some graph this way. So a linear function behaves this way. It's a line, right? It's a line. Could be a positive line or a negative line. Okay. Now, a linear function is a function whose graph is a line. Linear function can be written in the slope-intercept form of a line. So this is what we call the slope-intercept form. That is y equals to mx plus b. So this equation has meaning. Well, we do know that y is the output, m is the slope, x is the input, or what we call the independent variable. B is the y-intercept. For example, if you have a graph like this, and you have the line behaving this way, the point through which the line passes through y-axis is called the intercept. That is the y-intercept. Another way to see that is to say b is the initial or starting value of the function when the input x is 0. You can see from my graph here that x is 0. Let me draw this very well so that you can see it clearly. Okay. Say I have some graph. Okay, I'll make this downward to give me space. Okay, so suppose I have some graph behaving this way. Now, I have some line. I have some line behaving this way. So you would see that when x is 0, there is a value for y. That value for y is called b, which is the y-intercept, and it is written as in point form. It is written as 0, b. That is x is 0 there, then the y value is b, whatever the value is on the y-intercept. So an m is the constant rate of change, which is also called the slope of the function. The y-intercept is at 0, b, just as I showed you now. So meaning that if we have y equals to mx plus b, we will have our y-intercept when x equals to 0. That is when the input is 0. And that is y equals to m times 0 plus B. Therefore, y equals to 0 plus B, and y equals to B. So that is why we have our y to be B here, and x is 0. So, and that is why we call it y-intercept. Remember, when the input is nothing. A way to think about it in terms of business is you want to start a business, even when you have not produced, you've not made any sale, you've not had any, uh, made any money, you've already, you know, spent some money, even when you have not produced anything. For example, you will pay for rent, you pay for workers, even when you have not produced any item. So such cost is called a fixed point or the intercept when your input is 0, or when the items you have produced is 0 and it is nothing. Okay, consider the following. The pressure in pounds per square inch, that is the unit, the pressure in pounds per square inch, PSI, on a diver depends upon a depth below the water surface in feet. A certain situation is modeled by the equation P of D equals to 0.434 D plus 14.696. Restate this function in words. Well, from what I've explained earlier on, you will see that P of D is the pressure that depends on, that is P depending on D, is what is the pressure, is the pressure on the, is the pressure on the diver. Uh, which depends on, which depends on the depth, the depth, uh, on the depth the diver goes in, beyond the surface. So that is the meaning of POD. Now, what about these other parts? Now, we can say, so you see, I call this M. Remember, this is P of D, which is MD plus y-intercept, or P-intercept. So if M is 0.434, what it means is that, and look at it, 0.434D. So what it means is that for each foot that the diver goes below the surface of the water, the pressure increases by 0.434. I hope that makes sense. So for each foot, for each foot um, below water surface, the diver, the diver, the diver's let me say the pressure, the pressure, the pressure on the diver increases. How do I know that it is increasing? Because the number here is positive. If it is negative, it means the rate of change is decreasing. Okay, so the pressure on the diver increases by 0.434 0.434 psi. It is that. Now, lastly, 14.696. If you again connect it to B, which we call the y-intercept, that is when the input is 0. That is when D is nothing. So in this sense, it means at the surface of the water, at the surface of the water, that is when the diver has not even, stepped like this, when the diver has not gone into the water. So at the surface of the water, the surface of the water, the diver experiences, we say the pressure on the diver is 14.696 psi. Does that make sense? So that means when the diver has not even gone any foot into the water, the diver is experiencing 14.696 psi. So now for each foot that the diver goes into the water, there is a pressure of 0.434 added to 14.696. Now, which means if the diver goes in by, say, 10 feet, then all what you need to do is to multiply 0.434 by 10, then you add it to 14.696. Okay. All right. Now write the example 2. Example 2. Write the following function in tabular form in slope-intercept form. Remember what we mean by slope-intercept form. This mx plus b. Some textbook will call display c. It doesn't change anything. It's the same thing. Okay. Well, in this case, our y is d. Our input is t. So instead of y, I'm going to write d of t, d, that is, the distance is depending on time, right? Okay, d of t is, and the input is, let me use another color for you to see. Okay, the input is t. So d of t is mt, right? Plus b. Now, what do we need to find? We need to find the slope, and we need to find the intercept, right? Now, how do we find slope? If we look at this, if we look at this table, what do we notice? We notice that when the time moves from 0 to 1, that is one, we don't know if it is hour or second or minute, but let us presume that we presume a unit, let's say second. So when it moves from 0 to 1, so that is 1 second, the distance changes from 250 to 333. Before I continue, look at the 0 here. What does that mean? It means when there is no time at all, the distance covered is what? 250. Oh, we have the unit. It's in seconds. Yeah, it's in seconds. Okay. So the distance is meter. Okay, that's cool. Okay, the distance covered, or the distance we already have, is what? 250 meters when the time has not increased. Now, when it moves to 1 second, what is the change? That is 333 minus 250. Let's see, what do we have? We have 313 here. That is 83, I believe. So that is 83. It also moved from 1 to 2. That is another step, another second. So let's see how many meters. So that is from 333 to 416. Let's see what's the difference. So that is 3, 1 here, 11. So that is 8. Again, we have 83 meters, 83 meters. And apparently, I believe this is 3, this is, yeah, also 83 meters. So it means that for every second, there is a change of what? 83 meters per second. So that is the rate of change, which is the slope. Okay, so now we can say d of t is m, we know it, 83 t plus our b. Remember, b is y-intercept. In this case, d-intercept. That is when the time is 0. So when the time is 0, d is 250. So we just add it here. And the unit for this, because it is distance, so the unit is meters. Okay, so have we answered the question? Yes, write the following function in tabular form. D of t measured in meters is the total distance covered in time t in seconds. So that is the answer. Now let us look at increasing and decreasing function. The slope determines if the function is increasing or it's a decreasing linear function or it's a constant. So we have this situation. Remember, we always read graph from the left to the right. So reading this graph from left to the right, we'll see that the graph is, the y value is increasing as we go from left to right. It is increasing. However, here it is decreasing as we go from left to right. The y value is decreasing. However, here it stays the same. So we say it is constant here. Now, what does that tell us? Well, in the case where it is increasing, we say the slope. It means that the slope is positive. It means the slope is positive. And when it is decreasing here, it means that the slope is negative. Here, the slope is positive. And here, the rate of change is 0. That is, it is not changing. Okay. Now, let us formally find how we calculate the rate of change. That is the slope. How do we find the slope? Okay, from this graph, from the graph I'm having here, now I'm going to, I have a straight, line. I have this line, and then there is a point here, and there is another point here. So in your high school math, you've learned that slope is rise over run. Rise means y, run means x. That is change in y over change in x. That is the meaning of rise over run. Change in y over change in x. So if I have the 2 points and I draw, I make a, well, I call it right triangle there. So you can see if I'm reading my graph from left to right, you will see that the y value is increasing. So I'm expecting that in this situation, the slope should be positive. But well, that is not what we want to do. Let us look at this. At this point here, I call it x1, that is value x, the first x, not this one, but the first x. And now at that same point, I have y value for it. So that is the first y. So x1, y1. Now, at this point, there is also a value of x. If you trace it down, there is also value of x. I call it x2 again, not these two. That is just a coincidence. Okay. So the second x, and then there is also y value there. So I call it the second y, y2. So x2, y2. Now, we said slope is rise over run. That is, how far has y changed from from this point, y1 to y2, from here, the rise. So you can see, since this is increasing by unit of 1, 5, 6, 7, 8. In fact, you can see that the change there, the rise there is 1, 2, 3. 3 units. It has changed by 3 units, by 3 over change in x. So how have I changed from here to here? Just to 1, right? Just 1. Then I will claim that the slope there is 3. Okay. Now, formally, we say m is change in y over change in x, right? Which is the same thing as y2 minus y1, just like what I did here. 8 minus, right? I hope that makes sense, guys. So 8 minus 5, that is y2 minus y1 over x2 minus x1. So this is your guide. This is the formula for calculating slope. So m equals to y2 minus y1 over x2 minus x1. So that is the formula for computing slope of a straight line, Okay, let us take example. If f of x is a linear function, it has to be linear function for you to use that formula. And 3, -2 and 8, 1 are points. They are points on the line. Find the slope. Let us go back to my illustration here. You see, just like here that I have 2 points. I have this point and I have this point, right? 2 points. Given 2 points, the slope of a linear function is this. So now look at this. We have 2 points. Given these 2 points, we want to find the slope, which means, look at what I'm going to do now, guys. I'm going to say, I will just come to this point. I can call this x1, y1. Then this one will be x2, y2. So the slope is change in y, that is rise over run. Okay, so which is change in y, y2 is 1. This is y2, 1 minus y1 is -2. So I will carefully write it like that. Divided by x2, which is 8, minus x1 is 3. So that is 1 plus 2 divided by 5. And the answer here is 3 over 5. So m is 3 over 5. Now the second part is the function increasing or decreasing? Well, f in this case is an increasing function. How do I know that? How do I know that function? Since the slope is positive. Since the slope is positive. Okay, so you can pause this video and just do the same thing that we did there to find the uh, slope of that line that has 2 points, 2,3, 0,4, and determine if it is increasing or a decreasing function. Now, we have studied linear function written in slope-intercept form, but that is not the only form in which we can write equation of a line, of a straight line. Now, another form is what we call point-slope form of a linear function. So,